On the first exam for 408S, you're going to get several integrals to do. And what's a little different about the exam from the homework is that you're not going to be given any hints or help about which technique to use to do the integral. It will simply say compute. It won't say using substitution or using integration by parts. The covered techniques for this exam are substitution, integration by parts, and just plain old integrals. We started the semester with fundamental theorem of calculus and the net change theorem, which means just using antiderivatives. So looking at this integrand, I have to choose one of these three things to do. I don't think substitution is an appropriate choice, and I don't think it's an appropriate choice because I don't see a relationship, a derivative relationship between the numerator and the denominator. For example, the derivative of the denominator is 1/2 x to the negative 1/2. I don't really see that up here. I don't see the derivative of the top inside the bottom. So I really don't think that's going to work out. Integration by parts may work, where I guess if I were going to try it, I would have u equal to the numerator and dv would be x to the negative 1/2 times dx. I have no idea if that's going to work, but really what I'd like you to see is that we don't really need either one of those techniques for this problem, because we can use algebra on the integrand and make this guy so much easier. So to get this problem started, what I'm going to do is rewrite the radicals as fractional powers, which helps me see how to simplify the integrand. All three terms in the numerator have to be divided by x to the 1/2 power, and that means subtracting those exponents. So, for example, well, x to the 1/2 divided by x to the 1/2 is 1, and x to the 2 divided by x to the 1/2 is x to the 3/2. So this integrand simplifies quite a bit, which makes the antiderivative kind of a joke. It's just the reverse power rule. What's a little more tricky is plugging in those limits of integration so that you can get a numeric answer. Notice that 4 to the 5/2 power means take the square root of 4 and then take it to the 5th power. And so that is actually equal to 32. And so I start simplifying this answer. This is 4 minus 6 times 2, which is negative 8. 2/5 times 32 is 64 over 5. 1 minus 6 is equal to negative 5, and obviously this is just 2/5. I get out a little fraction math, and I arrive at an answer of negative 77 over 5. Here's a second example which I think is deceptive. You see this product of trig functions and you start thinking that integration by parts is the way to go here. Additionally, I think sometimes we're fooled by this x plus. You think that that should somehow matter, but it's plus. It's plus, and plus means that right away we know that we can do the antiderivative of x separately from the antiderivative of this product of trig functions. So I'm not going to let that x worry me even a little bit. Now before you go jumping to integration by parts, I would like to coach you to remember to memorize your trig derivatives. This guy is literally the derivative of cosecant. And so, well, it's the negative of the derivative of cosecant. So if you can see that, this problem actually goes very, very quickly. The antiderivative is x squared divided by 2 minus cosecant x. And so because I know that, right away I can plug in those limits of integration and actually do a little bit of work to simplify this answer. Now, sine of pi over 3 is equal to radical 3 over 2, which means that cosecant of pi over 3 is 2 over radical 3, and sine of pi over 6 is 1/2, so cosecant of pi over 6 is 2. And I'm looking at this and I'm thinking, I'm really not going to be able to make this much prettier, so I'm going to call this good. So here's what I'm saying. You're in a high-stress environment, it's a 45-minute exam, and you need to step back and ask yourself, is this problem simple? Don't bury yourself in 15 minutes of computation when maybe just an antiderivative will suffice. Not every problem on this exam is integration by parts. So be sure to check if the integral is easy.